Right.
Progress.
We had to start with 2018. So this is 2018 paper. Yeah. Okay. So this is 2018 A level structured essay question number 1. So we have to discuss only after 2018 only two more papers, right? Only two more papers, that is 2019 and 20. Then we have done 10 years papers, general chemistry, under general chemistry structured essay, all the questions, question number 1. After that I'll be starting the revision of fourth lesson and the fifth lesson, that is behavior of gases and that means the states of matter, and thermodynamics or energetics, that is unit 5, both under physical chemistry, right? Unit 4 and 5 under physical chemistry. Okay, those we have done. Now the first question also we can polarizability of halide ions increases. Yeah, polarizability we have learned. Yeah, we can discuss. So this one, you know what is polarizability, right? Polarizability of halides. Halide means what are halides? Group 7 elements. So halide means group 7 elements: fluorine, fluorine, chlorine, bromine, iodine. Right? Halides: fluorine, chlorine, bromine, and iodine. So actually down the group, what happened? The size increases, right? Atomic radius, atomic size increase. And then happened to the polarizability of these ions, that means fluoride, chloride, bromide, iodide. No? Halide ions. Yeah. So increases with the increase of size, that means down the group it increases, polarizability increases. They are asking whether it's true or false, but reasons are not required. But anyway, this kind of questions is more advantageous for the students because 50% the chance. Now if you get a MCQ you have 5 answers, 5 options. That is the 25% the probability. Like if you are doing a Kana shot, here the Kana shot 50% the chance, either true or false. But anyway, they are asking reasons are not required, but you have to be very careful. Some A-level papers, they have given for each now this true and false statement, they give a condition like this: each correct statement 2 marks, each the correct answer 2 marks, and the wrong answer negative -1. They right, and therefore if you don't know, like either true or false, you can put one of these now any student without reading the question even, then they will deduct marks. Sometimes you can get 0 marks, right? Because 2 corrects and 4 wrong, 2 correct 4 wrong, then it's like what, +4 and -4 0. Yeah, 2 marks for correct one, -1 for the wrong one, then 0 mark, like that. So if you can't decide that, you have to leave that blank, then they will not evaluate that. Is that clear? But anyway, they have not given that here. Okay, so you have those who have done, you can post the answer on chat. Right, first one the answer. Don't put everything at once. All the students, please forward the answer for the first one. So put Roman number 1, and whether you can write even one letter even enough. Capital T and capital. No need to type it because you can use the time spent for typing. You can reply on chat. Sorry. Okay. Now, yeah, all of you are correct. Ransiluni Tisat, Chaniti Dinetmi. Yeah, well, very good. All of you are correct. It's true. Chaniti Tisat. Yeah. What were the others? True. Abdur, have done this. Right. All of you are correct. So actually now they are not asking the reason, but I want you to write this separately in your short notebook, right? You add separate, because you should learn this, how polarizing power. So if when is cation, we call it polarizing power. When is anion, we call it polarizability, right? Look at the screen, everyone. Look at the screen. So write a small short note on this polarizability. I told you we are doing this paper class not just to mark the answer, because just to mark the answer you can look at the marking scheme, right? So when it's come to the cation, look at the screen, everyone. When it's come to cation, we call it, that means positively charged ion. That is called polarizing power. What is called polarizing power? When it's come to the anion, we call it polarizability. That is polarizability. Cation polarizing power, anion polarizability. This is under general chemistry. I think you most probably you might have learned this under theory class. Polarizability. Right. Look at the screen now. A small cation. Okay, when it's become polarized in power, the small cation has higher polarized power. Small cation has high polarizing power. High polarizing power. That means if you take Na plus, Li plus and Na plus, which one has higher polarizing power? Na plus, small cation. Small cation has high polarizing power. High polarizing power. Example, write example. Li plus has higher polarizing power than Na plus. Because when the cation is small, electrons of the anion can be attracted more strongly. If you only write that, when the cation is small, under that also you can copy down this. When the cation is small, ability of attracting the electron cloud of the anion is higher. That is called polarizability. When small cation can strongly attract because the distance to the nucleus from the outermost shell is less. Small cation can strongly attract the electron cloud of the anion. Can attract the electron cloud of the anion. Can you all see at the bottom? I don't know whether can manage it, right? Small cation can strongly attract the electron cloud of the anion. That is called polarizing power of anion. Because when it is small, electrons are strongly attracted to the cloud. Electron cloud is strongly attracted to the nucleus of the cation. Right. So, opposite of this, if you take anion, please copy down this short note. This will be very useful. Polarizing power, here polarizability. So, a small cation has high polarizing power. I will copy down. Everyone should maintain a separate short notebook for the class. Then at the end of the revision, each section, physical, organic and inorganic, you will be collecting very useful short notes. Very useful set of short notes. Anyway, I will the hardest lessons anyway I'll be giving you a separate short note like this. Right. Then next one. Right. Look at the screen. Polarizability of an ion. So large anion has higher polarizability. Example, Cl minus has higher polarizability than F minus, fluoride ion. Fluoride ion is large, and larger the anion, higher the polarizability. Larger the anion, higher the polarizability. Any questions on this? Now, please copy down this. Then I'll take these two examples. Now look at the screen. If I take LiCl and LiF, lithium fluoride and lithium chloride. Right? Lithium chloride and lithium fluoride. What matters here? The polarizability. Cation will influence. LiCl and LiF. Look at the screen. So here the cation is same. Then what will affect? Anion. Therefore, this one has more covalent character, because here what happened? Lithium chloride anion If it is fully ionic, it's like two ionic spheres. So actually what happened, we expect F minus Li plus and Cl minus to stay as two separate ionic spheres. Two separate ionic spheres like this. It's fully ionic, pure ionic. But actually what happens, due to the influence of this cation attract the electron cloud of the anion, then this electron cloud of the anion Cl minus get attracted to this side, right? Then it has some covalent character, right? Then LIF. So LIF that is less actually. LIF that is less. If you take F minus and Li plus, that also if you take if it is actually if it is pure ionic, they exist as two separate ionic spheres. But actually what happened, Li plus, so this is one set, and LIF cannot attract that much the anion because anion is small. Then that influence is little less than it attracted, but less than in Cl minus. Cation cannot attract much. So therefore covalent character, which one higher? This shows more covalent character. LiCl shows more covalent character. It shows more covalent character. Why? Because it tends to become more covalent, because electron cloud of the chloride ion can be attracted towards the Li plus. Then it's like higher covalent nature, because nothing is 100% ionic actually, where it's like the ionic compound has a certain extent covalent characters. It shows more more covalent than, shows more covalent character than what LIF shows more covalent character than LIF with compared to the LIF. So with compared to LiCl, this one is what shows less covalent character, that means it's more ionic. Less covalent means more ionic nature. Is that clear? Therefore when the anion become like cation, now it's neutral because both same. I mean LiF and LiCl, cation is same, and is the will affect the covalent nature and the ionic nature. Is that clear? Do you want me to explain that again? Did everyone get it? Therefore polarizability can be used to explain the covalent and the ionic nature of ionic compound. Covalent and the ionic nature of ionic compound. Covalent nature of ionic compounds can be explained using this polarizability, polarizing power. Now here polarizability effect, but when it comes to the other side, I'll take if I change the cation. Now this is anion. Let's see the cation, influence of the cation. So I will change the cation and keep the anion same. I take LiCl and NaCl. Then what matters? LiCl and NaCl. How to now which one has more covalent nature? Which one has greater influence on the anion? Li plus. Li plus has greater influence of the anion than Na plus, because the small cation has higher polarizability. Cl minus electron cloud is attracted more towards Li plus, but when it comes to Na plus, that polarizing power is less. So Na plus, so it tends to become more covalent actually. Na plus polarizing power is less. Na plus cannot attract much the electron cloud of the anion. It's like little less than that, right? So then what happened? Who is going to be more covalent here? When the electron cloud is attracted more towards the cation, it shows some covalent nature. So this one is more covalent. Who is more covalent? LiCl, more covalent nature. This one is less covalent nature with compared to the other one, less covalent nature. Right? Don't mix up this. Don't try to compare this with electronegativity. Then you get confused. Some students, they are going to compare the electronegativity and decide the covalent ionic. That is a different story. right? That's a different story. So here, covalent nature and ionic nature we can explain using the polarizability of anion and polarizing power of the cation. So what are the two factors that affect your cation size and the anion size? So anion, large anion is good, and cation, small cation is good to get more covalent nature. If you only write right, to get more covalent feature, what is better? Large anion and small cation. More covalent feature means, I don't have space, right? More covalent means small, more covalent feature. If you want to get more covalent character, then what? Cation should be small, anion should be large. Small cation and large anion. Small cation and large anion is better. I don't know whether you have learned this in your. This is like the complete thing under, because this is introduced new to the syllabus. This is introduced new to the syllabus. Frequent papers, recent papers, frequently they have asked this even under MCQs. MCQs they can give two compounds and or maybe four answers, and they can ask which one has the, which one of the following has the highest covalent feature, or which one of the following has the highest ionic feature character. Is that clear? Please raise the hand those who got it, those who understood this. Please raise the hand those who understood this. Good. Dinatmi, you have a question? Any doubt, or do you want me to explain any part? Dinatmi, are you okay with this? Others raise the hand. Right. Okay. The next one. Dinatmi got disconnected. Right. Anyway, shall I erase this? Anyone still copied on? Please raise the hand, and if anyone of you are still copied on this. Right, I will erase this, right? Okay. Why did I explain with some parts, some questions I'll be explaining bit in detail. Why? It is so important. It is so important for the upcoming papers, right? Then number two. Can you all please post the answer to the chat? The second one. Number two. Quickly post the answer to the chat. Dinatmi, you are disconnected. Are you okay with that? The previous explanation, or if you have any doubts, please let me know. Done? Right. Okay, some of you have already posted the answer to the chat. Second one. True. Ramsiloni, Tisat and Chaniti gave the answer. Yes, very good. That is true, right? I put one letter, but in the paper you had to write the full answer. Yeah, very good. So previous one, do you want me to explain? I think Dinatmi is getting disconnected and again connected. So I mean, she must be experiencing bad internet connection. So then you can, even if you experience in the middle, you can request the recording, right? So let me explain next one. NO2 is greater than NO2 minus. Look at the screen now. Second one, please copy down the explanation in your separately. Please copy down that the explanation for this. NO2 and NO2 minus. So let's see the structure of NO2. NO2, it's like this. It has odd number of electrons. NO2 has odd number of electrons. So NO2 minus is like this. NO2 minus and NO2. There's only one electron. Here there's a plus charge, here minus charge. and this one NO2 minus, there will be two electrons, one lone pair, and then like this. So repulsion between bond electrons is greater. So NO2 bond angle is greater. Why? The repulsion is less. I mean from the, okay, I'll mark the repulsion from the lone pair. So this, from one electron the repulsion is less. Here there will be a repulsion, bonding pair, lone pair repulsion. What is this? BP, that means non-bonding electrons. Non-bonding electron, non-bonding electron and bonding electrons. Repulsion, it's less. Repulsion between what? Bonding, there's one non-bonding electron and there are bonding electrons. So that is less in this. Why? Only one electron causes the repulsion. Here, two electrons involved in the repulsion. That means lone pair. Here actually what happened? There's a lone pair here. Lone pair. So this one causes more repulsion. This one causes more repulsion. More repulsion. I put lone pair, bonding pair repulsion is greater. Because two electrons cause more repulsion than one electron. Therefore, when the repulsion is more, what? Bond angle is less. This bond angle here is less. Here the bond angle is greater. So the bond angle will be greater. This is greater. This is smaller. Bond angle. Therefore, that is true. NO2 bond angle is greater. And the other thing is, please write here, this is a molecule with odd number of electrons, because nitrogen 7, 2 oxygen 12, right? 2 oxygen 12. So out of the valential electrons, or if you take, I'll take the total electrons here. So this one has oxygen atomic number 8. So if you take the total electrons here, 8. Nitrogen total electrons 7. Then you get what? 7, 8 into 2, 16. 8 into 2, 16. Then you get what? 16 plus 7. Right. 2 into 8. You get 16. 16 plus 7, you get 23. So this is a molecule. Please label this a molecule with odd number of electrons. That's why we get 1 electron. Molecule with odd number of electrons. Molecule with odd number of electrons. Molecule with odd number of electrons. So actually Lewis, you can't draw the Lewis structure for a molecule with odd number of electrons. That is one drawback of Lewis theory. You can write that in the, add this to a short notebook. Lewis structure cannot be drawn for a molecule with odd number of electrons, because Lewis theory, only the pairs of electrons, that means all the electrons should be in the form of lone pairs and bonding pairs. All the electrons should be in the form of bonding pairs and lone pairs in the Lewis structure. That is like one condition in the Lewis theory. Therefore, Lewis theory, one drawback is what? Lewis theory has failed. Lewis theory has failed for the molecule with, or the ions with odd number of electrons. Lewis structure cannot be drawn. That is one drawback of Lewis theory. Please write it. Huh? Right. Then, so can you understand this? So when the repulsion from one electron is less than from two electrons. Than from two electrons. Then number 3. Shall I erase this? Anyone still copy now? Right. I'll erase the screen. Number 3. London. Okay. Can you please forward the answer for the third one? Third one. These two are true, right? This one. What is the answer? London dispersion for the CCl4 molecule smaller than London dispersion from a SO3 molecule. True or false? The third one. Third one. Who can forward the answer for the third MCQ? Third one. Now part 3. CCl4, which molecule is greater? London forces strength increases with the increase of what? Size of the molecule, right? When the molecular size increases, please copy down this, everyone. When the molecular size increases, London forces increases. When the molecular size increases, what happened? Strength of London dispersion forces increases. Strength of London dispersion forces. Strength of London dispersion forces increases. Right, increases. When the molecular size goes up, strength of London dispersion forces increases. Right. Only one. Others how to. Okay. So which one is greater in size? So the size of which molecule is greater? CCl4 or SO3? So CCl4 molecule is what? Greater in size. Size of CCl4 molecule is greater than SO3. Because there are 4 chlorine atoms. Chlorine. So chlorine is below fluorine, that is in the third period. Oxygen is in the second period. Right? Therefore, size of CCl4 is greater than SO3. Therefore, London dispersion forces. London dispersion forces. Strength of London forces greater in what? Strength of London forces greater in what? CCl4. CCl4, the strength of London forces is greater than SO3. SO3. Is that clear? Now everyone should be able to give the correct answer for this. When the size of the molecule increases, strength of London forces increases. So which one has greater strength of London forces? Can you all post the answer now? Only Tisant and Chaniti gave the answer. Number 3. What about the others? Ranasrini also gave. Good. Abdul, what is the answer? Are you there? Look at the third statement, Abdul. Yes? It's true. CCl4, London forces in CCl molecule is smaller. They are telling me smaller. But actually it's greater. In CCl4 they are telling me smaller. But actually look at my the explanation, the summary. When the molecular size goes up, the London dispersion force goes up. But then they are telling smaller. In the statement they are telling smaller. But actually it's greater, no? In CCl4. Yeah. So that's false. Now remember, any A-level paper, the students lose about like 5 to 10 marks. 5 to 10, most, like not everyone, most of the students, they lose 5 to 10 marks. Lose 5 to 10 marks due to careless mistake. Due to what mistake? Careless mistake. So what happened then? Your A can become lose 5 to 10 marks due to careless mistake. So that is for not following, not adhering to the instructions given, not following the instructions given, not reading the question properly, or calculation error, units missing. Oh, they are asking. So therefore, exam is not only the chemistry knowledge. They are checking whether you are careful about and whether you get exact. You are writing the answer to the exact point, and then whether you are using the technical terms when you are writing your answer, or else you know the answer, but it is not reflected in your written when you are writing. So something else, the reader cannot, not the same thing that is reflected. That means like communication problem. What you thought is not reflect the written skills. That matters, no? Because A-level exam means what you write they assess, no? Not what to actually your thinking process will directly affect that, but some students what they think not cannot be expressed in written. That's one of the major problems. Some if we ask them orally, they nicely explain, but when we ask them to write, then it is not reflected in the same way. So that still you have to develop by answering questions. There's no other short method for that. You have to learn it by doing it. Therefore, don't lose 5 to 10 marks. Now you can make it. You can't make it perfect, but anyway, you have to make your maximum effort to do minimum mistakes. So I'll give one example. If you become a surgeon, okay, so like very few neurosurgeons in our country. If you become one day a neurosurgeon, those who are doing bioscience, so or heart surgeon, so you are doing 100 surgeries per, okay, 1,000 surgeries per year. Out of 1,000 surgeries, only one death due to the medical negligence. So 9%, okay, 999 patients recovered and done it well. Very successful. That also anyway they don't release that to the public, but the hospital, the statistics, so they have it. So this doctor, this much of surgeries, and then this much successful. Right? So if you know the internal stuff, they know about this. But anyway, we go for the most popular doctor, mostly seeking the most popular doctor. But actually, the surgeons, so that matters. So that means we need the people in surgery or even in any other profession, even engineering, those are doing the minimum mistakes. So they have a very good knowledge about the subject. They are very skillful, but so that is also one very important factor in your profession. Okay. So they are going to select the people with minimum errors or minimum mistakes. Most careful. Okay. Right. Because of your simple mistake, you can't tell no. That's a very simple mistake. Therefore, can excuse no. Sometimes out of 6 tablets you prescribe to the patient, one go wrong. So sometimes it can cause death. It can cause death. So remember that not only doctors, even the medical MLT, medical laboratory technicians, they are performing, they are analyzing the sample or pathology lab. So then report go wrong. The report is wrong because of personal error. Sometimes it can become physical factors or environmental error or poor sample or cross contamination. There are various reasons now. Because sometimes you might see the people. Sometimes one place the PCR is positive, the other place it's negative. Sometimes antigen is positive, but PCR is negative. That can happen, right? So it's like these kind of issues they are in any laboratory. I mean, that is reliability and repeatability. Reliability and repeatability. Right? And reproducibility. Reliability, repeatability, and reproducibility. So therefore, if you do the same test of the same person in different labs, you get the same result. You get the same result. So it's reproducible. Right? Repeatability. In the same lab, you repeat the same test again and again. Right? Repeatability. So that is how you can validate that. You can validate it. Right? Otherwise, what happened? One lab this. So then you have to. There's a problem with the report. So if the report go wrong, what happened? Doctor will prescribe the wrong medicine. If the report goes wrong, doctor will prescribe the wrong medicine. At the end, you blame the doctor for the side effects, but at the end what happened, the MLT has done a mistake. Remember that. So science, so when you're dealing with science, you have to be very careful. We need the best people, most accurate. No one can become 100% accurate, but we need the most accurate people. Accuracy and precision must be very high. But actually the other countries, the A-level students and O-level students, they teach this. What is accuracy, what is precision, what is repeatability, what is reproducibility. in limit of detection, limit of quantification, like that. There are various very advanced techniques. But in Sri Lanka, like fully exam oriented, that's one of the major problem. And the other one is uncertainty or significant figures. Very one day definitely you will learn this in the university, but A level it's less in our syllabus than in the previous international syllabus, right? So anyway, the reading the questions we have to be very careful, Abdul, right? Okay, so they're asking smaller London forces, larger molecule, having greater London forces, but here they are telling smaller, therefore that is false. Right, let's move on to the next question now. Part 4. I hope everyone of you are copying down under each answer the explanation also, because that then only your chemistry knowledge is on improving. Even if you do 100 papers with any teacher, if you are just marking the answers only, you will not improve. Remember that, unless you get the same question in the exam again. Part 4, the shape of HSO4 minus. So that also very good question. The shape of HSO4 minus, that is what is called hydrogen sulfate or bisulfate ion, is trigonal bipyramidal. Yes, can you all post the answer to the chat? You should better draw the structure of HSO4 minus. So what is the central atom here? Central atom is sulfur. When you get a central atom is sulfur. So first you put the central atom sulfur. Let's draw the structure and let's see how many bonded pairs, how many sigma. What matters for this? The shape means what shape here? If they give just the shape of the molecule, that means it's referring to the molecular shape, right? The shape of the molecule or the molecular geometry. It's called molecular geometry or ion, not electron pair geometry, right? If they just give the shape, that refers to the molecular geometry, not electron pair geometry. So molecular geometry is what matters for the molecular geometry. Sigma bonds and lone pairs. What matters here? Sigma bonds and lone pairs. 5 bonds are not considered for this. Sigma bonds and lone pairs, not the 5 bonds. That also very important. Right. Then let's see HSO4 minus ion, the structure. Look at the screen now. Sulfur is the central atom. This remember most of the acids. Hydrogen is not directly linked to the sulfur atom. Hydrogen is not directly linked to the sulfur atom. Hydrogen is linked through the oxygen atom. So that is very important in HNO3, H2SO4, most of the acid H2CO3. Remember, hydrogen is not directly linked to the central atom. So it's linked with, say example H2CO3. It is linked with the not directly linked. If it is directly linked, what happened? You cannot release that hydrogen. So this through the 2OH group, dibasic acid. It has, this is H2CO3. This is H2CO3. H2SO4 actually has 2 OH groups. 2 OH groups like this. Look at the screen here. Always the oxygen link all the hydrogen through oxygen to the central atom. After that, the remaining oxygen atoms directly link to the central atom. Again, I am repeating that. First, you have to link all the hydrogen through the oxygen, and after connecting all the hydrogen through the oxygen to the central atom, remaining oxygen atom you directly attach to the central atom. Don't ever directly attach the hydrogen atom first, then you are in trouble. So these are called oxyacids. Nitric, sulfuric, carbonic acid, even any other, even if you take acetic acid, HCl3COOH. So it's like hydrogen is not directly like this name. CH3COOH or acetic acid, CH3COOH. It's like this. There's a OH group. So if there's only one OH group, we call it monobasic. If there are 2 OH group, dibasic. If there are 3, tribasic. Right? So you can see here H2CO3, H2SO4, CH3COOH. So number of OH group. So here also HSO4 minus bisulfate ion. Actually, how HSO4 minus ion is formed? When H2SO4 ionize, when sulfuric acid ionize, it become HSO4 minus. It become HSO4 minus. That means what? One oxygen is, imagine this side, the oxygen is going out. If this oxygen is going out, then what happened? It become HSO4 minus like this, oxygen. Then you get double bond O. Then here OH group is there. Then this become O minus. That means it's leaving by giving electron. Look at here. This is H2SO4, sulfuric acid. This is after ionization, it becomes HSO4 minus ion. HSO4 minus. HSO4 minus. Right. So this is OH. Always first link all the hydrogen through oxygen. After that, the remaining oxygen, if when there is a minus charge, that is oxygen, negative charge carries always on the oxygen atom. Therefore, there are 4 oxygen and 1 oxygen with minus charge. There will be 3 electrons on that, 3 pairs of electron. So this is how it looks. Now you can check HSO4 minus. Actually, what happened here when it is ionized, H2SO4, it becomes HSO4 minus plus H plus. So it's ionized. It releases 1 proton. So this is ionization of complete ionization of sulfuric acid into HSO4 minus and H plus. Again, it can ionize into H2SO4, and if you can form the other acid also. Again, it ionizes like this, HSO4 minus, and again become SO4 2 minus and H plus. But that is reversible. That is reversible. That is reversible. That's very important. Double-headed arrow. This is reversible. Is that clear? HSO4 minus. HSO4 minus again ionize into this. Right. Therefore, HSO4 minus, it does not ionize completely. Some students think H2SO4 directly become in single step 2H plus and SO4. That is wrong actually. Sometimes we write like this, but actually it happens in 2 steps. Sulfuric acid, strong acid, but it does not release both the hydrogen ions simultaneously. One hydrogen is released and become bisulfate ion. Then bisulfate ion again release H plus and become sulfate ion. Okay, so this is because I am telling this upcoming lessons, physical chemistry, ionic equilibria, acid-base equilibria, you need this knowledge. So the general knowledge, general chemistry, actually general chemistry means like general knowledge of chemistry. So that will be useful when you are from when you are doing the the other lessons under physical chemistry. Therefore, you should better copy down the structure of H2SO4 and HSO4 minus ion. So how many sigma bonds here? Sigma bonds, how many sigma bonds? Both H2SO4 and HSO4 minus. There are 4 sigma bonds. There are 4 sigma bonds. When there are 4 sigma bonds and no lone pairs, what is the shape? 4 sigma bonds, no lone pairs. I put no LP. LP means lone pair, right? Then, when there are 4 sigma bonds, what is the shape? Around the sulfur atom. Yes? What is that? It is? Okay, who can tell me the correct shape? Can you please post the answer to that? No lone pairs, 4 sigma bonds. Huh? Tetra? Very good, yeah, tetrahedral. Very good, tetrahedral. Tetrahedral. So please write it, HSO4 minus ion, tetrahedral. Because there are 4 sigma bonds. 4 sigma bonds. No lone pairs. 4 sigma bonds, no lone pairs. No pairs. 4 sigma bonds, no lone pairs. Right? So, even H2SO4 also is tetrahedral. And one more thing. Who can tell me, additional thing I am asking now. Who can tell me the hybridization of this atom? What is the hybridization of sulfur atom? Who can tell me the hybridization of sulfur atom here? Quickly post the answer to the chat. What is the hybridization of this sulfur atom? SP? What? SPO, SP2, SP3? Yeah, Tisat gave the answer, Ransulani gave. Yeah, earlier also the Ransulani and Tisat, you replied tetrahedral, very good. Yeah. So are replying active participants of the lesson, very good. I don't mind whether it's true or false, but if you are replying at least the answer, I am very happy. I know you actively participate in that. Yeah, right. Very good, all of you are very good. Sometimes some students think, sir, anyway I know this. No, what is the point of posting this again? The other students will post the answer. No, so I'll just stay silent. Don't do it, because actually that is very good. You know, if all of you are doing this, so then the teachers also get some confidence about all the students. Not only my class, even the other class, always communicate properly with the teacher. It really helpful, not for the teacher, even you will be benefited. Then teacher can understand the level of the students you are up to which your standard. very easy. It's easy. It's a very helpful teaching process. Okay, so then can very advanced or simple or slow or fast, so that teacher can adjust that based on your responses, right? Okay, so therefore it false. So that is false. No, not trigonal biprivileged. It is false. How many of you did this? Please raise the hand. Those who got the fourth one with understanding, with the correct structure. Those who have predicted this statement false. The part 4. Those who understand. Very good, very good. Right, all of you are done it well. Anyway, you can copy down anything you want here. Especially copy down here sulfuric acid, H2SO4. Even though it's strong acid, it ionizes in 2 steps. So this is the step 1. First step, it become bisulfate ion. Next step is reversible. Next step is reversible. First step is complete ionization. Right, I'll erase the screen now. Okay. Let's move on to the part 5. Right. Part 5, what is the answer? Can you all post the answer to the chat? One more thing, remember this, okay, can you write this also, this carbonic acid, H2CO3, hydrogen carbonate, that also same story, right? H2CO3, it's like this, ne? H2CO3, so it's dibasic. So H2CO3, first it becomes HCO3 minus, HCO3 minus and H plus. So what is the structure of HCO3 minus? It becomes like this, O minus. So imagine this electron is H plus is given when the electron then it's become minus, H plus is leaving. The other side it's OH is there. In the next step what happened? This is a reversible thing. It's a reversible one. It's not that's a weak acid. It's partially ionized, not complete ionization. It's a double-headed, means reversible reaction. So again what happened? HCO3 minus, this HCO3 minus again will become CO3 2 minus, CO3 2 minus. But here you can see the geometry around carbon won't change. Even though it's ionized, what is the shape here? It's the upcoming papers, they can ask this one again. That's why I'm telling this. Then it becomes CO3 2 minus. Then this side become O minus. It's already minus, ne? So already minus this one. This also become what? Minus. This also become minus. This also become minus. Minus. So then, will the geometry won't change? Geometry won't change. All three the same geometry around carbon atom. All three the same geometry around carbon atom. So this HCO3 minus ion again become CO3 2 minus. So it's that happens in 2 steps. This happens in 2 steps. It won't happen in single step. Very, very important. So it becomes CO3 2 minus and become H plus. That is carbonate ion. Carbonate ion. So this is H2CO3. This is HCO3 minus, because here given HSO4. Upcoming paper they can give HCO3 minus and they will ask the shape here. That's why you always gather some like, even though your answer is correct, try to learn something new under each carbonate ion. Also trigonal. Okay, when the only 3 sigma bonds, no lone pairs, only 3 sigma bonds, no lone pair. Therefore this is trigonal planar. All 3 trigonal planar. This also trigonal. Trigonal plane. So this is also trigonal plane. Trigonal planes. All 3 around the carbon atom geometry trigonal plane. So please copy down that also. Very good. And the hybridization, very good, Rana Siruni. It's sp2 hybridization. So they will change the same thing they ask, even old syllabus or new syllabus sometimes under this. Only thing they will change the structure, or the ion or the molecule. So this is sp2. All 3 sp2. the hybridization of the carbonate sp2, right? sp2, carbonate, bicarbonate, and carbonic acid. Carbonic acid. Sometimes the students write H2CO3 like this. That is wrong. You can't write H2CO3. Becomes completely 2H plus and CO3 2 minus. That is completely wrong. Why it is wrong? Why it is wrong? There are two. Now tell me two mistakes in this reaction. Now if someone write like this, what are the two mistakes here? H2CO3 become 2H plus and CO3 2 minus. What is the mistake here? One mistake is it won't release simultaneously 2H plus. The second problem, this is not a this is a reversible reaction. This is a reversible reaction, right? So it's not unidirectional, because if it is like this, then it should be a strong acid. Carbonic acid must be a strong acid. Is that clear, everyone? It has to be a strong acid, right? Okay. Very good. Then next one. Should be written in 2 steps and yeah. Okay, run student, very good. Charges also not balance. Okay, right. Okay. Then I'll erase this. Let's move to the next part. So you learned something new from this, not just the answer. Right. Then part 5 also there. Part 5. Look at the screen. Part 5. Part 5. All 3D atomic orbitals of an atom are represented by quantum numbers. So they are the 3 quantum numbers for 3D. 3D. Forget about the question here. Let's write 3D. The 3 quantum numbers. Okay, you can post the answer quickly to the chat. 3D. What is the value of n? N equal. It's 3. L means what? So L 0 means what? L can have the value 0, 1, 2. So L0 means it's S. L1 means is P. L2 means D. L can have the value 0, 1. So here it's 2. That means L should be what? It's D. Sorry, it's 2 here. Sorry, it's 2 here. That is correct, no? That is correct. So N is 3, that is correct. L is 2, that is correct. And then ML can have the values from -2 to +2 through 0, no? -2 to +2 through 0. Right. So then you get what? -2, -1, 0, -2, -1, 0, +1 and +2. So that's why you get 5 d orbitals. D5. Each orbital can accommodate maximum 2 electrons. So L equal 1 does not represent all the atomic orbitals of 3D. So actually the last one only wrong. Other two are correct. Last one only wrong here. So ML equal 1. So it does not represent all the atomic orbitals of 3D. All the atomic orbitals of 3D. ML should be what? -2 to +2. Oh, no, because they are telling all. Because look at here, look at the screen. Highlight the word because pay attention to the this is called active word. What is called active word of the question? There's something called kriyakari vachane. Active word of the question. All here. All very important. Underline that. So please, okay, again I am telling, if there are 50 words in a question, if the number of words in the question 50, all 50 not equally, you don't need to put the same weight or the same strength. Some words you have to pay more attention than the others. Be honest. Please raise the hand. Those okay. Anyway, you have given the answer. Maybe even distance is false. But anyway, those who understood, those who noticed this, the last one is wrong, and the word all. Because of that, this went wrong. With that understanding, those who got the answer, please raise the hand. Tisat gave the correct answer. Abdur gave the correct answer. Tisat and Abdur, Chaniti also gave the correct answer. When you are posting the answer, put the question number also, because part 5 Roman number. Otherwise, because from time to time I'm looking at the chat, then Abdur and Tisat correct, Chaniti correct. Ransel is not there. And she is there. Only Dinatmi left. I think she has a connection problem. Right. Okay. So is that clear? Any question? So right here, ML1 does not represent all the atomic orbitals. So does not represent, yeah, all they are all does not represent all the atomic orbitals. All the atomic orbitals. That's why it's wrong. Understood? Have you all started? Please raise hand those who have finished the 4th lesson, because after this we have to do 2 more papers only, 19 and 20 only. After that I will be doing physical chemistry. I will be starting the revision. Tisat done completely, Chaniti done completely. Translini, have you started at least half of the lesson done? 4th lesson. Abdur done, right? All this. Translini. Then because next month I can start physical also, right? Anyway, not even started, so it's still unit 3. Ransulini is still unit 3. Yeah, sir, I don't go to the school. Okay. You are doing privately now. Okay, right. About third unit revision, actually bonding revision I have done, Tisat, because you joined recently. In the bonding we did revision. Right. Anyway, if you want, you can those who join late, those who are you can join the 2024 A-level batch now this May. But anyway, I'll take some time. Maybe after about 3-4 months I'll be starting, because anyway I'm doing only revision. I'm not doing theory, because I have so many classes, and with the ministry work and zonal education office work, so then I find it difficult to manage the time. Therefore, earlier actually I did both theory and paper class, but now I am doing only the paper class of all the LL badges, revision class. So, but that also successful. Some students they perform very well, because others they are doing the second shy, but you do the first shy and second shy both at once. Kind of revision also you do it. No, mostly what happened, they complete the theory syllabus and then face the exam. Many students. But now you are doing the complete revision of 20 years papers, all the lessons. So then it's a very good experience. So then you are well prepared, you get more confidence. That's good. But earlier, now only it's coming, right? Okay. But before that, some students still what they are not doing revision, they are not thought about the paper class or revision class. They're still doing the first few lessons theory only, theory class. Right. So this one is false. Is that all? There's one. Okay, or there's one more part. I'll erase the screen. If you are in doubt, please raise your hands. Highlight the word active. Active words. You have to pay attention to the active word of the question. Part 6. Part 6. Part 6. The addition of an electron to a gaseous phosphorus atom. Gaseous phosphorus atom. Gaseous. Exothermic process. Highlight the active word. Addition of electron, highlight. Exothermic, highlight. To whom? To phosphorus. Exothermic addition of electron to phosphorus atom. Then gaseous, it's endothermic. How to analyze this? For the nitrogen is endothermic. Phosphorus, it's endothermic, this is exothermic, right? Phosphorus, it is exothermic, nitrogen is endothermic. Please forward the answer to the chat, those who have done it. Addition of an electron. Yes. Ransuluni, Tisat, Chaniti gave the answer. What about Abdur? Okay, Janji, you're asking some past paper structured and essay questions from the unit 3 like this. Yeah, okay, sure. Yeah, okay. All of you get the same answer. It's correct. Yeah. Right, very good. Very good. Well done. All of you are correct. Right. Difference between electron gain and affinity. Actually, it's like the old syllabus, so they use both. Actually, electron affinity and electron gain enthalpy. Electron affinity they use in general chemistry. Electron gain enthalpy they use in energetics or physical chemistry. Electron gain enthalpy, the standard conditions are used. Electron affinity actually is general chemistry. The no standard conditions like the standard pressure, standard temperature not used. If when it comes to enthalpy, you will learn under chapter 5. Who asked that question? Ransiloni. Right, Ransiloni, the electron gain energy. Actually, we call it electron gain enthalpy mostly. No problem, Dinatni. You can get the recording for that one because it's very important. The previous one I gave a lot of explanation. Each part, you can get the recording. Please request the recording after. I'll send the recording for the one that you miss. Right. Are you experienced now today? There's no power cut, right? Anyone of you are experiencing power cut at this time? No, right? I mean, the usual power cut maybe only like accident maybe your area, but normally island wide there's no power cut now, right? Okay. Anyway, so remember, electron added to gaseous phosphorus. Look at the screen now. Right. This is how you should do it. Nitrogen has half-filled 2p orbital. Nitrogen half-filled 2p orbital. Nitrogen. So that is 2p3. 2p3. Nitrogen. So it has extra stability. It has extra stability. 2p1. It has extra stability. Right. But so adding an electron to the stable configuration should be broken. When you add in an electron to nitrogen, the stable electronic configuration should be then what happened? Electron density then it's become when nitrogen atom is small, the electron density also become higher. When adding electron, it will strongly repel. So therefore, nitrogen atom will repel the electron. It doesn't like. Nitrogen atom will repel the electron added. Will repel it. Will repel. Therefore, nitrogen atom will repel the electron. Will repel the electron. Then what happened? It's endothermic. When it repel the electron, that electron, therefore electron gain enthalpy is what? It's endothermic. Therefore, when it repel, it's endothermic. Therefore, it's endothermic. It's endothermic process. endothermic. So in case of phosphorus, what happened? That also has 3p3 configuration. This is 2p3. When it's come to the phosphorus, look at the screen. When it's come to phosphorus, the outmost 3p3. That also has the same the stable configuration. Okay, can you all hear me? Because I think there's a power cut today. So now I am experiencing the power cut. Runs Dinat me. How many hours you got the power cut now? I hope it's half an hour, right? Just now I think power went in our area. Can you all hear me? Anyway, I'll try to manage it because 1.5 hour power cut. Oh, okay, 1.5 hours, no, right? Anyway, now it's 6:12. We'll okay. We'll continue because I connected through my other device. We'll continue like this. Okay. Right. I'll share the screen again. You can see the screen, right? Always keep your device fully charged at all the times now these days, and you should have a backup like mobile to make a mobile hotspot, or the smartphone. You should have internet because router is not working when there's a power cut. Right. So I was explaining the last one. Okay, look at the screen. I explained, I think the previous part is missing, but I'll quickly write here. Nitrogen it's NP. Nitrogen and phosphorus, the difference is 2p3 and 3p3. 2p3 and 3p3. When is nitrogen and phosphorus both half filled configuration, although it's 3p3, the size of the atom is large. Therefore electron density is less. Therefore electron gain enthalpy is exothermic. So what matters here? 2p3 and 3p3. Look at the screen, everyone. So nitrogen 2p3, phosphorus 3p3. So therefore here the stable configuration Here also stable configuration. Here also in the stable configuration, but this one what happened? High electron density because 2p3. So that if you take 1s and 2s, what is the difference? 1s it's bit electron occupied in less area, high electron is 2s. It's both having the same shape, but the size different. 2s and 1s what? The size different. That this one has higher electron density. High electron density. This one has low electron density. Low electron density. So same thing here. Please highlight electron density in 2p3 is higher than 3p3. Electron density is higher in 2p3. Therefore, when the electron density is higher, when an electron is added to this to make it 2p4 and 3p4, 2p31 endothermic, it more repulsion, and this one not much repulsion. So this one more repulsion here. More repulsion. Therefore, it's endothermic. Endothermic. When it's come to phosphorus, electron density will be low than nitrogen atom. Electron density will be less than nitrogen and therefore less repulsion. Therefore, it's exothermic. Anyway, remember adding an electron to an atom is it's always exothermic. It says exothermic. What matters here, but the other factors also will influence because it's like making an attraction between the. It's like a bond making. Bond making is exothermic. Bond breaking is endothermic. Bond making exothermic. Bond breaking endothermic. Therefore, here the electron density is comparatively low. Therefore, electron gain enthalpy is exothermic. Electron gain enthalpy is exothermic. So, usually electron gain energy or electron gain enthalpy is exothermic. Usually it's exothermic. So, therefore, less stable config, but less electron density. So, here electron density in 2p3 is higher. That is the main point here. Electron density higher in 2p3. Electron density in 2p3 is higher than 3p3. Is that clear? Right. So therefore, more attractions. Your electron, the attraction here. Attraction of electron to the nucleus. And because it's large in size, large. Here is small. Size also different. Therefore, this is exothermic. So, adding an electron to atom is same as bond making. Interaction between what? Electron and the nucleus interaction is there. The added electron and nucleus, there's an interaction. That is equal to what? It is same as bond making. It is equal to bond making. Making a bond. Making a new interaction. Making a bond. Bond making is what? Bond making is exothermic. Bond breaking is what? Giving away electron. Giving away electron is what? It's like breaking a bond. That is always endothermic. Giving out electron is what? Same as bond breaking. Bond breaking. Bond breaking is what? Bond breaking is endothermic. Therefore, ionization energy is always what? Therefore, I put I here. Ionization energy is always endothermic. Ionization energy will never become exothermic. Always endothermic. Why? Breaking of the attraction between the nucleus and the electron, outermost electron. So again what? Look at the screen here. Please copy this in a short notebook. What is this? Giving out electron, bond breaking. It's equal to bond breaking. Giving away electron. and then therefore endothermic and ionization energies, therefore ionization energy is always endothermic. But electron affinity or electron gain enthalpy, it can be exo or endo. Please write here. Electron gain enthalpy can be exothermic or endothermic. Can be exo or endo. It's both possible. Exo or endo. Can be exo or endo. Can you all please copy down this quickly? Electron gain enthalpy can be exo or endo. Right? Adding an electron is same as bond making. A removal of electron is same as bond breaking. Are you all copying down this? Okay, done. Shall I erase this? Anyone still copying down? Anyone still copying down? Right. I'll erase this. So that's all the first part. Then next one, part B. Wait. One more thing. Please raise the hand those who got all this correct. All 6 parts correct without before I explain. Those who got all this correct. Please raise the hand. All 6 correct. Dinatpi Chanityan Tisat. Abdur and Ransulini, how many correct and which one is wrong? Okay, sorry about that. I have mentioned. Now this one SF3N. There are two things. Either you can annotate on my screen. I have given the permission to annotate on my screen, or else you can. If you want me to share the screen, I can give the permission to share your screen, and you can show me the answer. Or else, because you can't post the answer to the chat, there will be structure, right? It's difficult. So there are three options. There are three options. You can annotate on my screen, or else you can share your screen, or else you can, as a file, you can post the answer to the chat. So anyone, any volunteers to share the screen for this one, the answer? Raise the hand, then I can give the permission to share. Now thing is, you have to take a photograph and share that. That's it. You can share your screen, that photo. Yeah. Okay, Abdur Regan, F single bond on top, on up, down and left with three lone pairs, and nitrogen with triple bond with one lone pair. Okay, okay. Right. Anyway, I'll draw the answer. You can check with the answer. Now there's, if you are doing online, now there's something called like writing pad or drawing pad. You can, I think you can, it's not very expensive. It's around cost starting from 5,000 onwards. You can attach that to your USB drive, and then you can, it's very easy to communicate with the teachers when you're doing online classes. Even the students will be benefited, but most of the teachers are using that, but you can use a like a normal one, or else if you are using the smartphone, you can annotate on the screen. Because some of the, when drawing the structures and the resonance and all, like, it's kind of, you will experience a bit difficult, no? Okay, when sharing the answer, right? Now what is the central atom? Okay, first let's see the central atom here. What would be the central atom? What would be the central atom? Sulfur, nitrogen, no, fluorine. What is the least electronegative one? Least electronegative is sulfur. Least electronegative one will be the central atom here. After that, fluorine anyway connected with single bond. Fluorine linked with a single bond. Single bond. Then nitrogen, most stable one is what? Sulfur can go up to sulfur expanded octet possible. Central atom plus it can have expanded octet. Expanded octet possible. Expanded octet is possible. Right? Sulfur is the central atom as well as the expanded octet possible. An expanded octet possible. Right. So therefore, nitrogen, the most stable arrangement with triple bond with the central atom. Oxygen with double bond. So we go for that because since expanded octet possible. If expanded octet not possible, if sulfur cannot accommodate more than 8 electrons, this is not possible to draw like this. So how many now? 6 bonds. 6 bonds. Now is this correct? What is missing here? Can anyone comment on this? This is not 100% correct. Why? What is missing in my Lewis structure? Sulfur all 6 electrons used up for the bond formation. Sulfur all 6 electrons used up for the bond formation. And what is missing now in my one? Lone pairs. Okay, very good. Ransulni Abdur. Yeah, lone pairs missing. So then fluorine, around each fluorine atom 3 lone pairs, 3 LP. Around each fluorine atom 3 lone pairs. Like this. And around nitrogen only 1 lone pair. Okay, please raise the hand those who got this with correct lone pairs. How many of you got this correct? Very good. Yeah, very good. All of you got me. Very good. Right. Then full marks for this. If you want, I'll give the marks also according to the marking scheme. This one carries 8 marks. 8 marks. Previous one 6 into 4, 24 marks. 24 Right. So I'll erase the screen. Next one. Number 2. The stable, most stable Lewis structure for C3O2. Normally there is only one most stable Lewis structure. This paper they have asked the most stable Lewis structure for C3O2. Right. They have given here. Draw another two Lewis structures for this, or that means resonance structures. When there's possibility of drawing more than one Lewis structure, we call them resonance structures for this molecule. Marks will not be awarded for the Lewis structures drawn with the octet rule violated. With octet rule violated, no marks awarded. Marks will not be awarded if you violate the octet rule. Octet rule, right? Now what is this? C3O2. C3O2. You asked to draw three other resonance structures. How to share the answer? I assure Abdur, you can pray and come. No worries. Okay, good. Then please raise hand those who have done this. Part 2, those who have done the resonance structures of this. All of you have done, right? Very good. Okay. So I'll draw it. Now 1 is given, so you can draw the same one again. You can, okay, one more thing. Can we change the skeleton? Now, can we change the position of the carbon atom? When we are drawing the resonance structures, can we change the skeleton? Can or can't? Can we change the position of the atoms in the linear one, or the central atom? We can't. Remember that we should not change the skeleton. When drawing the Lewis structures, now usually we don't change the skeleton. Very important, right? Therefore, we don't change the position of the carbon and oxygen atoms. We can change the bonds, the arrangement of bonds only we can change, right? Okay, good. Now, what is the requirement here? For the octet rule, carbon can have multiple bonds. Carbon can have multiple bonds. Carbon can have multiple bonds. So I will do here carbon, I can have triple bond. Carbon, I can have triple bond. So I'll make between these two triple bond, and this one single bond, like this. Carbon cannot go carbon octet. Remember, both oxygen and carbon cannot go above 8 around the central atom. That's also very important. Cannot form more than 4 bonds. Therefore, then this side you get carbon triple bond, single bond, oxygen single bond. So this side you make triple bond like this. That is one possibility. Then you can draw the Lewis structure there. Then next one I put the 3 carbon atom. This side carbon I'll make the triple bond. Right. Then this becomes single bond. I'll highlight that. This side I'll make triple bond. In this one, this side triple bond. Right. Then it's oxygen here. Then you have to put the to make this one also you can't put 6 bonds. Then this one you make triple bond here. Triple bond. Then you have to put the lone pairs, right, to make it octet. You have to put lone pairs. Sometimes whenever oxygen is local, this is very important. Whenever oxygen is linked with a single bond, oxygen carries a negative charge. It's very, very important. Whenever oxygen is linked with a single bond to any atom, oxygen carries minus charge. Okay, look at this. Oxygen carries minus charge. Then when there are 3 bonds on oxygen, it carries plus charge. When there are 3 bonds on oxygen, it carries plus charge. Positive charge. And there will be 1 lone pair. Because out of 3 electrons for the bond formation, out of 6 electrons, 3 for the bonds, and 1 lone pair, 1 is gone. Here also 1 lone pair. Because you can't put anyway oxygen valence 6 electrons. You can't make it 6. You can't put 1 dot here. Right. Okay. plus, because anyway when you put minus charge on the other side, it's a neutral. So when you put minus charge on the oxygen with single bond, then definitely the plus charge should appear, positive charge should appear on another atom to make it neutral, plus and minus neutral. But you can't put the positive charge on carbon. Why? Carbon, its octet is completed, no more electrons left, as well as all 4 electrons are allocated. All 4 electrons allocated for each carbon. Each carbon, all 4 electrons allocated. All 4 electrons allocated. Therefore, carbon octet is completed. Carbon octet is completed. Please raise the hand those who have done these two structures. They are asking how many draw another 2 Lewis structures. Okay. They are asking to draw 2 Lewis structures. Done. But if you want, you can draw 2 more. Right? You can have different elements. So double bond and triple bond combination also possible. You can have, but it is highly unstable. Carbon, this side triple bond, and this side you can have this also possible. This side triple bond also possible. This is also possible. Then the other combination, this side triple bond carbon oxygen, then this side you put triple bond, and then carbon and oxygen like this. This is also possible, but you have to put the lone pairs and charge. These also accepted. And carbon, all this. This one not this carbon. This carbon, then you get 2 minus charge. So then 2 lone pairs and 2 minus charge on this carbon. Right. Just a lone pair. There are 3 lone pairs. These two also possible. These two also possible. Minus and here plus. Yes, not so this is 2 minus, then this one become plus. Here plus charge, here plus charge. Here plus. Is there anyone who has done this one? These two? The highlighted one? Please raise hand those who have drawn these two of this. Highlighted one? None of you, right? Please raise hand those who have done the first two. I'll highlight them pink. These two, anyone of you have done this pink one? How many of you have done? Please raise hand those who have done the pink one. The first two structures? None of you. One pink and one grey. One from the first one and one from the second. Okay, right. Okay, good. Now anyway, you have draw any two of this, any two you can draw. So I have given here 4. You can draw any 2. But if you want, you can draw all 4 if you want. 1, 2, 3, 4. 4. Okay. Right. Shall I raise the screen? Anyone still copying down? Please raise the hand. If anyone of you is still copying down, please raise the hand. Or else shall I screen this? Shall I delete this? Right. I'll delete. Right. Then next on. Based on the Lewis structure below, to complete this, I'll quickly write here also a number in here. This is 1, 2, 3, 4. Right. So it's very easy. You can post the answer to the chat. This one. So done. You can post the answer. We'll do one by one, like downwards. Downward. Post the answer downwards, not horizontally down. Vertically down. Please C1 equal this. Put commas and write all 4 at once. Don't put N2 first. C1 all 4 answers downwards. You can put commas and write C1 equal this comma, this comma, this comma, this, like that. So VSC PR pairs here. VSC PR pairs means what? Only sigma bond in pairs and lone pairs. What is VSC PR pairs? sigma bond in pairs and sigma plus lone pairs. I put LP. Even electron pair geometry what? Depends on sigma bond in pairs and lone pairs. 5 bonds are not considered. So even this one only sigma bond in pairs plus lone pairs. The shape matters. Then hybridization also what? Only sigma bond in pairs and lone pairs. Only sigma bond in pairs and lone pairs. Okay. Now let's see. First one. C1 carbon. How many VSEPR valence shell electron pair repulsion? How many? 4. 4. Therefore what? VSEPR pairs 4. Then electron pair geometry. Because electron pair geometry is equal to the molecular geometry of the shape if there are no lone pairs on that. No, if there are no lone pairs, if you want to write that, if there are no lone pairs, if there are no lone pairs, then electron pair geometry equal, if there are no LP, please write that. If there are no lone pairs, electron pair geometry is equal to the shape. If there are no lone pairs, if there are no lone pairs, no LP, please write electron pair geometry is equal to the shape. Electron pair geometry equals shape. Is that clear? Therefore, this one you can copy down that under in your short notes. Electron pair geometry equals. So therefore, electron pair geometry will be here tetrahedral. Then the shape also around that. Not tetrahedral, sorry, trigonal plane. There are only 3 sigma bonds and only 3 sigma bonds. This one will be not 4, no, sorry, it's 3. Sorry about that. It's 3, yeah, okay. It's 3 here. 3. Therefore, I put trigonal plane. It's trigonal plane. This also trigonal plane. And hybridization will be what? sp2. Hybridization will be sp2. sp2. Okay, done. Very good. Ran Siluni correct. Dinetni, you have put tetrahedral sp3 and 4. Dinetni, that 5 bond is not considered. Okay. By mistaken, I put at the beginning 4. Okay, you understood it, right? You are talking about P4. P4. We are doing C1 yet. Don't pause the others. Only like one by one we'll do it. Otherwise, I'll find it difficult when reading the answers because I am commenting one answer. I mean, one part. Everyone I am commenting. Trigonal planar. 3 sp2 Abdul correct. Tisat correct. Chaniti correct. Very good. Dinetmi C3 also given. Okay. Run C4. No, don't pause the other because it's randomly. Then I have to read the answer. I'll mix up. Okay. Now everyone pause N2. Then it's easy in a row. I can easily read it. It's easy for me to read when everyone is posting the same answer. I mean the same answer for the same question. If you all are posting the answer for the same question, then it's easy for me to read, compare. Right. N2 now you can open. N2. Nadijana label as second Nadijan. So how many sigma bonds and lone pairs? 2 sigma bonds and 1 lone pair. 2 sigma bonds and 1 lone pair. It's 3 here. But there's electron pair geometry, trigonal planar same as that. But the shape of the molecular geometry will not be, because of lone pair, it become angular. And the hybridization will be sp2. Right, very good. Those we have posted Abdur, trigonal plane angular sp2, very good. Trigonal plane angular sp2, Tisat correct. Dineti, very good, correct. Ransiluni also correct. All of you are correct. That one is easy, no, not hard. Very good, all of you are correct. N2. Now C3. Can you quickly post the answer? Put commas and write the answer. C3 carbon atom label as no lone pairs. No lone pairs. Only two sigma bonds. Only two sigma bonds. And it's linear. And it's linear. And when there are no lone pairs, I told you the shape is equal to the, when there are no lone pairs, the shape is equal to the what? The shape is equal to electron pair geometry. Is that clear? Right. Then what is hybridization? What is the hybridization? Hybridization will be sp. Okay. Then last one P4. P4, yes, who can post the answer for P4? P4 what? Quickly post the answer for P4. Right. C3 all of you are correct. Linear SP runs correct. Abdur. Right. 4 tetrahedral sp3 4 tetrahedral. Okay. Dinesh be correct. Tisat correct. It's sp3. Yeah. Very good. Ran Siluni. Okay. Very good. Correct. Tisat Dinesh be Ran Siluni. Chaniti. Chaniti also done. Right. Very good. Right. Very good. Who didn't post the answer? Chaniti gave. Chaniti gave. Who didn't post the answer? Tisat. Abdur, no? Yeah. Abdur. Yeah, okay. You also done, right? Very good. Okay, right. Done. Okay. All of you gave, very good. All of you are correct. All of you gave the answer. All of you are correct. Very good, excellent. This one, I think you know this perfectly, no? Yeah. I'm very happy about that. All of you are correct about this. I mean, under this section, yeah. Mostly the general chemistry, that the other parts only that atomic radius, ionic radius, the bonding and all you had been in, right. This one is very good. Now please count how many blanks here. 4 into 4, 16 blanks. Out of 16 blanks, they have got 1 mark for each. LL paper, they have got 1 mark for each. Please raise the hand those who got 16 out of 16. All the blanks correct. 16 full marks. All correct. How many of you? Right. Tisat, Chanit, Dinatmi, Ransil, all of you have got. Abdur, which one you went wrong? Which one you got wrong? Okay, very good, others. Abdur, which one you got wrong? You got all correct. You raise the hand. Okay. Then all of you have. Okay, good. Right. Okay, Abdur. Right. Then I'll erase this. Let's move on to the next one. Right. Now I'm asking simple question, but anyway, I'm not in physical classes. Okay, I'm doing only online until your AL exam. How many of you are comfortable with online classes than physical classes with your past experience, and with you find it more benefit, like more benefit, no transport cost, no time waste, and it's safe, uh, and it's no I mean no need to spend time for ironing clothes and getting ready or putting makeup, and time waste and transport cost plus, like you can have more leisure time at home. You can do it leisurely while eating or while drinking or something, but in the classroom you can't do those activities. Fully this with those plus and minus both there, and you are experiencing good internet connection and good device. With all this you feel more comfortable. How many of you? How many of you? Please raise the hand. Those are comfortable, fully comfortable with online. Okay, good. Right, then no problem. Yeah, okay. Elements work. Both finds are when concentrated properly. Chanidi. I like physical compared to online, but it does not have more benefit. Okay. Give me a second. I'm getting an urgent call. Right. Let's see now. Again, we need to refer that structure again. No, I'll quickly draw. Shall I draw it quickly? So they ask in atomic and the hybrid orbital. I'll quickly draw it. C N. Right. Now, let's see. I'll quickly. Then it's easy to refer this now. Otherwise, again, I have to move up and down the page. So this is 1, here 2, here 3, and here 4. Right. 1, 2, 3. Right. So they're asking first F and C1. F and C1. Okay, you can post the answer. Part 1, you can post the answer. F equal this, C1 equal this, you can write. Or you can put comma and write respectively. 1, you can post the answer, everyone now. Can you post the answer to the chat? Fluorine, what is the hybridization? So in the A level paper, they accept both this. Actually, terminal atom, sometimes in A level, we don't consider that hybridized, so we take 2p. But if someone you write sp3 also accepted, since there are 4 VSC PR pairs. So either 2p or sp3, both accepted. And the other one, carb C1 is sp. How many 2 sigma bonds? So when there are 3 pairs, okay, if you want to write down this also, earlier also I gave this 2 VSCPR. Okay, so right here VSCPR means what? Sigma bonds and lone pairs. VSCPR pairs. VSCPR pairs means sigma plus lone pairs. Sigma plus lone pairs. If you get VSCPR pairs 2, what is the hybridization? SP, SP. If you get total pairs here 3, total VSCPR or sigma pairs and sigma bonds and lone pair, then you get sp2. If you get 4 total sigma bonds and lone pairs, it can be 2 sigma and 2 lone pair, like water. Now water VSCPR, that 4 pairs. How come 4? 2 lone pair and 2 sigma bonds. So or else sometimes it can be NH3, so 3 sigma bonds and 1 lone pair. So anyway, total 4 pairs. Total VSCPR 4 pairs. So then it's sp3. sp3. If there are 5 here, we call it sp3d, but it's not given in your syllabus. If there are 6, we call it sp3d2, but it's not given in your syllabus. You are getting only up to sp3. sp2 and sp3 only you are getting. Is that clear? Right. Then okay, most of you, Dinetmi and Ransiluni gave the answer. Chaniti, Abdur, 2PSP2, 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 2P. Okay, very good. All of you are correct. Both of you are, yeah, oh, very good. Give this. Anyway, it's like with the digitalization, you will get in the future. I told you, you get virtual laboratories also. You can do the practicals and all. Therefore, this becoming the trend is improving. Like it's like the number of English medium students, those who are in English medium A level and O level, that also annually increase in our country also. So this online thing also, it will never decrease. So in education in the future, they will offer universities online degrees also. You might not believe this sometime, like universities, private universities also, they will now most the, you might not believe, most the higher education institutes, diploma, higher diploma, certificate courses, the theory they teach online, only for the practical they have to visit. So there will be a time in Sri Lanka also in the future, the schools, they will call the physically the school only for the sports, only for the other extracurricular activities, and theory components will be taught online most probably. They no need to go to the all 5 days school. So it's like traffic, and you get exposed to more when you're going to a place, when you're going to the road, but you inhale more poisonous gases than staying at home, right? You'll have a makeup with all these dust particles and everything. So all these, there are health issues also there, right? If your school is within the Colombo, the urban area, like top schools in Colombo, I don't tell the name, but so Colombo, air pollution in Colombo more than in the other areas of the country. So every day when you're going for about 10, 12 years the school, like 13 years, every day you're going to the school. Highest, the air pollutants, the concentration highest the school hours ni, early morning and 1:30, because more traffic ni, more vehicle emissions, more vehicle emission. So therefore every day you're inhaling these poisonous gases. Sometimes the students will end up with a lung cancer or some other respiratory disorder, right? So respiratory disorders in the students in the western province more than in the other areas in the country. And the poor eyesight, vision also there are issues. Sometimes we think we are staying in the most developed city in the country, but remember that is the worst place to live sometimes. So physically you are getting more resources, but the others less mentally, and for your mental health and for your the to enjoy the nature, and air pollution, land pollution. What about so Kalani River, the most polluted river in Sri Lanka, most polluted one. So those issues also there, right? Anyway, now I'll move to the next one. Right. Okay, let's move on to the next one. First one I give the answer. Second one, you can quickly post the answer to the chat. Part 2. Yes, C1 and N2. C1 and N2. That means this one. This one. How many C1 and N2 only one sigma bond, no? C1 and N2 only one sigma bond. Okay. If you want, I'll quickly write here the hybridization if you want. So this one C1 will be what, sp2, right? This is sp, no? Then this carbon sp, this carbon sp2, no? Am I correct? sp2, sp2, right? Okay. sp2, n2, n2 also sp2, sorry, n2 also sp2, 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 sp, last one sp3, sorry, sp3, yeah, this is sp3. There are four, 1, 2, 3, 4, there are 4, yeah, sp3, right, sp3. Wait, this is sp2, this is sp2, this is sp, and this is sp3, right? Now Now you can easily get the answer. What? sp2 and sp2. Right? Actually, this is a stupid question. Why you did this in the previous part? No, I don't know why they are asking again. Earlier, look at the previous table part 4. Now this question is made to give some free marks for the students, those who are kind of to score easily, to score easily. Otherwise, no point of asking this, because previous one, the look at the table, the last row, the hybridization they have asked all these atoms, but now again they are asking. I don't know why. That is a poor question, I mean, kind of. Okay, anyway, C1 is good for the students. SP2, but nothing to teach here. Previous same thing. SP2. That's why I labeled the in the diagram. Okay, very good. All of you are correct. That also. But there can be careless mistakes sometimes, right? Even though it's easy, perfectly answer for all the parts, but you might do sometimes careless mistake. Then N2 and C3, N2 and C3, can you quickly post the answer? N2 and C3 what? SP2 and SP ne? SP2 and SP. So nothing to do. Look at the diagram here. I'll highlight this green. Look at this. Look. You can look at this. I highlighted as green. So you can look at this and quickly fill the blanks. Within 1 minute, you can do it. SP2 and SP. Then C3 and P4. C3 P4, you get SP and SP3. SP and SP3. P4 and CL, you get SP3 and SP3. SP3 and 3P also accepted. SP3 and 3P also accepted. Right? Is that clear, everyone? Okay. Please raise the hand those who got all 10 correct, 10 blanks, 10 out of 10. Marking scheme also, they have given 1 mark for each. Those who got all this correct, how many of you got all this correct? Very good. Dinatmi, which one you got wrong? Which one? No, Dinatmi, yeah, okay, which one you got wrong? Not all correct. Others all correct, no? Right, okay. Let's move to the next one. Good. Next one. Part 5. Sorry, this is also there are something new again. No? Part 5, they ask, identify the atomic orbitals and yeah, can you all quickly post the answer? These are not hardly hybrid. Right, very good. When it is atomic orbital, you had to mention that, right? Okay, so very easy. So this is N2 and C3, 2p and 2p. Ne? So if it is, so then it's not hybrid, 2p, 2p. This is 2p, 2p. C3. Formation of following sigma bonds in the Lewis structure given in the part. Involving the formation of the 5 bonds. No, 5 bonds. Remember, 5 bonds are formed always what? Hybrid orbital. Please put a stand, write this everyone. Hybridized orbitals, right? Hybrid orbitals will never form 5 bonds. Please write it. Put a stand, write with a red pen and write in a short notebook, everyone. Hybrid orbitals always form what bonds? Sigma bonds. Always. Please highlight the word always and then highlight sigma bonds. Always highlight sigma bonds, highlight what? Hybrid orbital, always sigma bond, never 5 bonds, never form 5 bonds. They will never form 5 bonds. Never form 5 bonds. Right. Then the other most important thing, s orbital also always form s atomic orbital. Any 2s or 1s or whatever. S atomic orbital also what? Always form sigma bonds, never 5 bonds. Always form sigma bonds, never 5 bonds. Please add this to your short notebook. Always form sigma bonds, never form 5 bonds. Never 5 bonds. Never form 5 bonds. And again, I put a stand, write this also. 2p orbitals. 2p atomic orbitals can form both. 2p atomic orbitals can form both sigma bonds as well as sigma bonds as well as 5 bonds. Sigma bonds as well as 5 bonds. Can form sigma bonds as well as 5 bonds. Is that clear? Please quickly copy down this everyone in the short notebook. Very, very important. Very, very important. So hybrid orbitals will never form 5 bonds. Always sigma. Always sigma. Any hybrid orbital. sp2o, spo, sp3o, whatever. Understood? Right. Please add this to because learn something new, because just copy down the answer, no need to come to the class, right? Then C3 and P4. C3 and P4 what? 2P and 2P. C3 2P. What did you write for P4? What did you write for P4? Is 2P. Yes. P4. P4, how many phosphorus can have vacant d orbitals? P4, you can write P4. Earlier we gave sp3, no? It has how many bonds here? 1, 2, 3, 4, 5. 5 bonds, ne? So sp3 can form only 4 bonds, ne? sp3 can form only up to 4 bonds. Can form up to 4 bonds. Up to 4 sigma bonds. Look at here. Up to 4 sigma bonds. Look at here. sp3 means there are 4 hybridized orbitals. So here all 4 sigma around. Look at here P4. Around phosphorus there are sp3 hybridization. sp3 hybridization, sp3 only, sp3 there are four sp3 there are four hybrid orbitals. sp3 there are four, 1 2 3, all at the same level. That means what? 3 from p, 1 from s combined. How to form sp3? 1 from s and 3 from p. Then it's mix like a food salad to make sp3. It's like 1 apple and 3 bananas. Then you get sp3. The name come because of the number of orbitals involved and the type of orbital involved in the hybridization. So therefore only 4 unpaired electrons can form maximum 4 bonds. So those are the 4 sigma bond. But 5 bond is the fifth one. Fifth bond cannot be formed by sp3. But in the marking scheme they have accepted sp3 also. Actually the best answer is 3D. The best answer is 3D, but A-level marking they have accepted sp3 or any other also they have accepted. Okay? But the best one is 3D. After that, after 3p you get 3D, 3s, 3p, 3D. So the phosphorus you get 3s, 3p and 3D. 3D is there. So they are p, all three you used up. They are all three used up. And here it's also used up. So actually what happened here, 1 electron from s can be shifted here. 3s2, 3p3 and 3D 0. So 1 electron from 3s2 can be shifted here. Then it's become 3d1. Then 3s1 and 3p3 and 3d1. So these two combine to become sp3. These two combine to become sp3. Look at here. These two combine to become sp3 and the other one 3d left. sp3, sorry, sp3. 1 from s, 3 from p electrons. So then 3d1 is. So that's how it can form these 5 bonds. It can keep up to 10 electrons. It can have expanded octet phosphorus. Is that clear? Yeah, true. Abdul telling the 4s should be filled first before 3d. But actually the electrons before 3d it goes to the 4s, but 3d orbital is vacant here. 3d orbital is vacant. Before the energy of the 4s is lower than 3. That's the reason for filling the least energetically least occupied one is 4s. That's the reason what here the electron vacant orbitals also can involve in the electron bond formation because of the exchange of electron between the orbitals. Right. Now please raise the hand those who got all 4 answers correct. But anyway, the P4, if you want, I will give free mark. Even if that kept blank, no answer or 3D or any other answer, they have given 1 mark for that. Anyway, you will be getting free mark like that even though it's wrong. So the P4 you get a free. Okay, very good. Right. Then next one, let's move on to the next part. Next one. Arrange the following in the increase in order of what? Increase in order of the property. Highlight the word increase in order. Reasons are not required. Reasons not required. First ionization is very easy. You can use the periodic table. First ionization is first check whether they belong to the same period or not. Do they belong to the same period? Let's see the ones with the same period. I'll highlight like this. Boron. Okay, first I'll see the same period one. Beryllium, boron, lithium, hydrogen, beryllium, boron, carbon, nitrogen is there. Right. Then so the pink ones, the second period. Pink ones belong to the second period. Then the others belong to the third period. Nitrogen, phosphorus, and lithium. Sorry. So this is third period one. This is third period. So if you take them the pink ones, it goes like this. Pink one zigzag pattern. If you get the pink one zigzag pattern, so then you get here. Look at the screen. Lithium, beryllium, boron, carbon, oxygen, nitrogen. Fluorine, neon. So zigzag pattern. Two right ticks, and you combine this. Add. Here you add plus. So this is the first right tick, this is the second right tick, and this is the extended one. So each long line, so this right tick you have to put 3 dots. This right tick 3 dots. And this one 3 dots here. Then 6 ne? 6 plus 2, you get 8. 6 plus 2, 8 here. So you get here 3, 3, 6, 6 plus 2, 8. Is that clear? So this is 3 here, 3 dots. Long line 3 dot, this one also long line 3 dot, and the extended one 3 plus 3, 6, 6 plus 2. But anyway, you have to remember the zigzag pattern, right? Short method. Now you can post the answer to the chat, part 1 if you want. Those who done it, those who understood and did it, you can post the answer to the chat. Now let's see the other one. So where's sodium and phosphorus? Sodium is below all this. Sodium is below all this. It goes here. Sodium. In that one you get again phosphorus. Sodium. Then you get like again zigzag pattern like this. Right? Sodium, magnesium. Then you get aluminium. Then you get silicon. Then you get phosphorus. P. Phosphorus. And now you can post the answer to the chat. Phosphorus. So first ionization is the lowest. What will be what? Sodium. Sodium will be lowest. Sodium will be lowest. So lowest sodium. I put Na. The next one. What is the next highest? I'll highlight the pink one here. Boron, beryllium. Boron there. Beryllium there. Phosphorus and nitrogen there. Phosphorus there, nitrogen there. Phosphorus and nitrogen. So nitrogen and phosphorus in the same group. Nitrogen and phosphorus in the same group. Definitely what? Group 5. Nitrogen and phosphorus. Group 5. Phosphorus lower than nitrogen. Phosphorus lower than nitrogen. Phosphorus lower than. Highest will be nitrogen here. Out of all this, which one has the highest value? Nitrogen. Nitrogen will be the highest. Phosphorus less than that. Then the other two will be what? Boron and beryllium. Which one is higher? Which one is lowest out of boron and beryllium? Boron lower than beryllium. Boron lower than beryllium. Look at here. So if you put, if you want, I'll put the numbers here. Lowest, number 1, sodium. After that, boron. After that, beryllium, number 3. Number 4, phosphorus. Number 5, nitrogen. That's how you get it. Please raise the hand those who got this correctly. I didn't look at your chat. Who is correct now? Sodium, boron, beryllium, phosphorus. Sodium, boron, beryllium, phosphorus, nitrogen. Abdul correct. Sodium, boron, beryllium, phosphorus, nitrogen. Chaniti correct. Sodium, boron, beryllium, phosphorus, nitrogen. Ransilonic correct. Tisat, sodium, boron, beryllium, phosphorus. Tisat correct. And Dinetmi correct. All of you are correct. Very good. Excellent. Right. All of you are correct. Done. So ionization energy, at least every year they ask at least MCQ. Right. Then electronegativity and ionization. Then number 2, electronegativity. Electronegativity. Yes, can you quickly post the answer to chat? Electronegativity, what is the, how to check? I told you repeatedly last few years, they have asked the factors effect in the electronegativity. They have raised the questions from the most of the papers. So ammonia, what are the factors effect in electronegativity? All these the same element, nitrogen. All this nitrogen. But what matters? The hybridization matters here, and the charge matters. Check the charge and the hybridization. Charge and hybridization matters here. What is that? Charge and hybridization. Right? And on the atom, the charge. Those are the 2 factors affecting. Yeah, can you post the answer to the chat? Those who done it? Yes? This one is little difficult with compared to the previous one. No? Previous parts, any student can get easily the answer. Okay, I'll quickly write near each hybridization with the red pen. Red. Above nitrogen, I'll write the hybridization. Ammonia, what is the hybridization? Quickly write it, everyone. Then it's easy. sp3. I'll write near this. sp3. NOCl. sp2. NO2Cl is NO2Cl sp2. Ammonium ion sp3. sp3 NO2Cl sp2 NOCl sp2 this one sp. Just draw the skeleton with the lone pairs and sigma bonds. Lone pairs and sigma bonds count around this. That's it. You have to draw the structure, otherwise you can't get it. Without drawing the structure, you can't decide the hybridization. Electronegativity depends on the charge on the atom and the oxidation state. So the other factors, charge and the oxidation number. What are the three factors? Charge, number 1, number 2 the oxidation number, and number 3 hybridization. What are the three factors affecting the electronegativity? All one nitrogen. Number 1 charge, number 2 oxidation number, number 3 hybridization. Number 3 hybridization. Again what? Charge, oxidation state and hybridization. Charge, oxidation number and the hybridization. Okay. Yes. Now so initially you can categorize like this: ammonia, NH4 plus, NOCl, NO2Cl, CH3. So can you all post the answer to chat? Which one has the lowest electronegativity? Ammonia. Ammonia has the lowest electronegativity. Because no charge on nitrogen and it's sp3 hybridized. S character is lowest. Lowest S character NH4 plus and sp3. But the problem is here there's a plus charge. Ammonium ion there's a plus charge. Therefore NH4 plus the electronegativity is higher than NH3. NH4 plus the electronegativity higher than. Why? Because of the plus charge. Because of the plus charge. The next one. Next has NOCl. The other one NO2Cl. Why oxidation number matters here? Here the oxidation number. You can check the oxidation number quickly if you want. Oxidation number. NOCl, nitrogen is more positive. NO2Cl, nitrogen is more positive than NOCl. More positive because they are more electronegative atoms, chlorine and NO2Cl. Therefore, it's always this way. Is that all they have got? Now there's one more, no? That blank I have not put it. Okay, I'll write at the end that one. Sorry for that. First blank, no space. Ammonia. Then the last one I'll write here. Don't worry about that. Then last one you get CF3 and C. Most electronegative. Why CF3 and C? sp hybridization. Look at here, out of all this one only has sp hybridization. sp hybridization. Ransuli asks how to draw the Lewis structure for F3 and C. Okay, I'll draw it. No worries, I'll draw it. How many of you got this correct now? Dinetmi correct. Abdur correct. Okay, Dinetmi and Abdur only. And Dinetmi, Tisat also correct. Very good. Tisat, Dinetmi, Abdur correct. Ransiluni and Chaniti. What about that? You didn't get this correctly, or which one you got wrong, or which one you got confused? Now, who is asking this? Ransulin is asking to draw the Lewis structure for this CF3. Okay, wait, I'll draw it. Carbon form, Ransulin carbon form 4 bonds usually. So you can draw like this nitrogen 3 bonds, 2. That is the most stable arrangement. You can draw here nitrogen, right? Nitrogen. Carbon, you can draw like this carbon triple bond nitrogen. Then again you can draw here carbon, and you can put here 3 fluorine. Then no formal charges, CF3CN, but they have an NZ to make you confused. Is that clear? This is the structure, Ransiloni. Last one. 3 lone pairs on fluorine. You can copy that if you want. Any other, if you know the structure, let me know. It's a waste of time, that's why I didn't draw all this. Done? Okay. Chanit is asking, sir, to find the hybridization, it is compulsory to draw the Lewis structure, right? Yes, because Chaniti, when you draw the structure only, you know how many sigma bonds and lone pairs. Without knowing the number of sigma bonds and lone pairs, we can't decide the hybridization. Okay, to decide, if you want to write it Chaniti there, right, to decide the hybridization of any atom in the given structure, to decide the hybridization, number of sigma bonds and lone pairs around that atom should be known. Again I am repeating, number of sigma bonds and lone pairs should be known to predict the hybridization. Therefore, to predict the number of sigma bonds and lone pairs, you have to draw the structure. You have to draw the most acceptable structure. Otherwise, you can't predict it. Clear? Right. Okay. Then shall I raise this? Any more doubts about this? So again I am repeating this. Please copy down this in a short notebook. Electronegativity depends on the charge, oxidation number, hybridization. Right? Charge increase, electronegativity increase. Hybridization, oxidation, when the oxidation number increase, electronegativity increase. That means its environment matters, right? Its environment matters. Sometimes what happens, a baby can be born to very kind-hearted parents, but he can become a thug later. So because of the environment he lives. So same thing, the nitrogen atom, we write the Pauling scale electronegativity 3.0. Nitrogen we write 3.0. That is the second most, the electronegative element in the periodic table. But oxygen 3.5, yeah, nitrogen 3.0. But what happened, based on the environment, it changes now. Depending on the environment, electronegativity can change with the oxidation state, hybridization, and so higher the S character, higher the when the S character goes up, then the electronegativity goes up. I put for the second arrow for the electronegativity, yeah, where it's going up or down, En. Please copy down that in under the summary. Okay. So how much time that we need to spend? Okay. Actually, that type of question means, I don't know, we are asking this part 3. It's like this, Chaniti. You can't exactly tell the time allocated because, okay, I'll tell one example. That's a good question you asked. You will get 50 MCQs, ne? 50 MCQs, 50 MCQs. So you are given 2 hours, ne? 50 MCQs in 60 minutes, ne? 60 minutes. But sometimes, based on your knowledge, sometimes one MCQ you might spend about 5. Is that clear? You cannot allocate the same time for all this, depend on the question. Now this question, you need more time, this one. But the previous in that table, you completed 16 blanks, that previous table, but you can do that in sometimes 1 second each. 16 seconds, sometimes maybe 30 seconds, less than 1 minute. But to complete 4 blanks here, it will take about 5 minutes sometimes. It depends on your the rate of thinking, and rate of analysis of this data. But the thing is, my advice, now don't think about the speed. Now the first round, when you are doing the questions, try to learn the correct concept. When the exam is closed, you can time and do the whole paper. Now one example, now we are doing the structure is a question number 1, the last 10 years now. Now we are doing the 2018 paper now. Then only 2 more papers. After that, we are doing the, once you complete the inorganic chemistry, I am going to do last 20 years question number 2 structured essay. Then once you complete the organic chemistry, unit 6 to 10, sorry, unit 7 to 10, the 5 organic lessons. Then we can do structured essay question number 3 and 4 until 2010. From 2011 onwards, only the 4th is structured essay, because from 2000 to 2010, even before that, from 1990s, 20 years, they have given 2 organic questions in structured essay, 2 organic questions. Then I will discuss. So then what happened? You can take, after completing all 4 structured essays unit wise, then you can do the entire paper at once. You can time and do it, because you have done this once, question wise, chapter wise. I think you understand what I'm saying now. Now if you are directly going to time in and do it, then you get really disappointed. You don't know how to do it. First you have to do the, first your accuracy and then the speed. First accuracy and then the speed. If you are inaccurate and the speed is there, then you are lost. Remember that. You have to accelerate. You should have the correct vehicle first. Then you can speed up. Otherwise what happens? If the nuts and the bolts or all these are not fixed to the vehicle properly, what happens? You will face severe accidents in the middle. You are thinking about only the speed, you are not thinking about quality of your vehicle. So here what matters, the quality and the concept, correct concept, then you can speed up, right? Okay. Otherwise, time also matters. The exam is not only answers, time management also very important. So both you have to improve before the oral exam. Okay, last part of this 2018 paper, quantum numbers. Quantum numbers also introduced to the syllabus in 2011 A level. Before 2011 A level, no quantum numbers. You will never find questions from quantum numbers before 2011 past papers. From 2011 onwards, they introduced this quantum number concept. Right now, there are 4 quantum numbers. They are telling quantum numbers electron atom is this. What is the question here? Energy of. Have I missed the question here? The energy of electron. That means you have to write that in the ascending order, no? Energy of electron in the ascending order. Lowest energy. So let's see. First, principal quantum number also tells us the energy. 3, 3, 2, 2s or 2p. So this is 3. So then if it is after that, I can decide whether it's okay. This one I put a curl because this is what. So it's, if it is 0, 1, 2. Okay, look at the screen. 0, 1, 2. This is the thinking process. 0 is, give me a second. Right. So what is this? So can you quickly write? So 0, 1, 2 S P D ni. 0, 1, 2 the L values. Values for L. Values for L. Values L0 S orbital, S subset, then 1 is P subshell and 2 is D. So now it is 3S here, right? 3P. So this is 3P. This is 3S here. This is 2 S here, 2S. This is 2P. This is 3D. 3D. So based on that, you can have some idea. So that means what? Third energy level, the energy greater than second level. Right? Second level. You can post the answer. Those who learn, you can quickly post the answer to the chat. You can quickly post the answer to the chat. Yes? Which one is lowest? Which one is lowest? I'll put the numbers here, right? Lowest will be out of this which one? 200, 2 is lowest. This is the lowest, number 1. Second lowest energy. Lowest energy is number 1. First we are write this. I'm not writing this. I mean, yeah, I put 1, 2, 3. Check the order. Then next one after 2s you get 2p. Number 2. After 2p you get what? 3s. Number 3. After 3s you get what? 3p. After 3p you get 3d. Actually, using the first two quantum numbers, you can predict the energy. To make you confused, they have given the other two. The other two are useless to predict the energy. To predict the energy, you don't need in this question, right? This question you don't need. So what is the correct order now? You get 2, 1, 1 half. Then you get number 3, 3, 0, 0. Then you get 3, 1, 0. Yeah. Did you all get it? No. She has left because she has a class at. Okay. It's almost 7:37. So we'll stop for today then, right? So this question is done. Please raise the hand those who got this correct with this understanding. Those who have analyzed 3s, 3p and 2s and then put in the correct order 1, 2, 3, 4, 5 like that in the ascending order. How many of you got this correct? Abdur, did you get this? These are some of you post the answer to the chat also, but anyway, I want to get a quick response. Abdur, you got it, no? Okay, very good. So then we'll stop for today now because it's 7:38, around 7:40 now. We'll continue the rest next day. Next Wednesday the same time, and try to complete this paper 2019 I gave today, right? 2019 paper. This paper complete 2019. So there's only one more paper after that, 2020 paper. 2020, have you all got the paper? 2020, no, right? Okay, so I'll post that. No, don't worry. Right. Okay, then good night and God bless you all. Complete 2019 paper before next class. Right. Okay. Good night, everyone, and God bless.